Alright, I want to do a quick vid on my latest project. I'm building a new autococker, and it's going to be a mech, but I wanted it to be a very special mech. I wanted it to be the kind of mech autococker that keeps up with just about any electro on the field. This is not something new. This has been done before, very similar, same frame. This is an Autococker Trilogy Select Fire frame. This particular frame is what you want to get if you want a very easy conversion. The conversion that I did was called, either you can call it a hair trigger conversion or a pneumatic trigger conversion, a PNEUCOCKER, a hair trigger, whatever you want. You see inside here, there's no electronics. There is a micro limit valve right here. It's an MSV2. Okay, it's the same one that they use in the pneumatics. All right. I did a few things differently. The first time I seen this was Badger on M. Carter Brown. He did it with the same frame, and then he did one with a center flag uprising, which is a really good frame for that, because the angles and the room you have in there, you can get a better angle on the lever for the valve. But I did a little work on this one to improve the performance with this valve in the setup. If you're familiar with Badgers, and he's got a couple of videos on here, you'll notice that my MSV2 is very high, it's very close, it's very short lever. The drawback of this is that it requires a little more force to pull the trigger, and I couldn't feel the difference. The positive side, which definitely outweighs the negative, is the amount of travel required to fire it is very little, about a 1/16 of an inch of travel, maybe less. I still have some tweaking to do. Alright, so that's the first thing I did differently. The second thing, he says is stainless steel rod. I did brass. Brass is self-lubricating. The more you use a brass moving part, the slicker it gets. That's just the way it is. Okay, then the other thing that I did, and if you haven't caught it or saw it or noticed it yet, you'll notice that my trigger is very close to the back of the frame. Anybody who's familiar with this frame knows that there's no adjustment to bring the trigger back. It sits out fairly far. It usually sits about out to here, which limits the space you have in here to work your fingers. Alright, which is a pain in the butt if you're trying to walk a trigger. But what I did was, when you take this out, okay, this is a splined push pin. It's press fitted. You got to push that out. Took the trigger out, and there is a spot on that trigger that looks like they were planning to put a set screw, which would make adjusting perfect. So what I did was drilled it out and put a set screw in, and it worked very good. It brings it real close. You can't see it on camera here. I wish I could show you, but the adjustment is right down in here. Okay, I'll show you. I'll make sure I got it in the set screw. I will bring the trigger out, and then I will bring it back. See here, the trigger is coming out. So there is a very nice, too much adjustment for the trigger there now, which was not original to this frame or trigger. The other thing I did is I grind off that little nub. I'm not a big fan of the little two-finger nub. It makes walking difficult. If it's here and a hit point for the best leverage is there, it gets in the way. So that's the main thing that I did that really, I think, improved the performance of this. Is get that trigger back, give you more room for your fingers. So let me show you at work here. Very, very little bit of travel, and it does not take much. I'm not using a straw like Badger, but I'm not really putting too much pressure on this. I mean, I'm holding it at the very edge. I'm able to press it. It's very light. I put the pin right on the edge of the lever so that there's as little friction as possible. I'm having trouble walking here. sloppy, but you can see that it's very fast. I mean, I can convulse my finger and get a quick firing. So it works, and you see how that's working here if you're not familiar. This obviously isn't connected to the trigger. In a mech, it would be connected directly to the trigger. When you swung the trigger, it would move that forward. So what they did for the select fire is they had this ram here, which pushes a little Delrin ram upward when you push the trigger. Okay, they had an electronic solenoid here that connected to the electronic circuit, which allowed the ram to push this to make it electronic. I don't know if you could see it very well. Let me get in there real close here. You can see that it's pushing up on the center of those two moving parts, the sear and the three-way actuator in there. So you can see how that works. Safety is very important on this, because on this frame when it's on a marker, because it doesn't take much motion to fire it, much pressure to fire it. Once you turn the air on, you're live. There's no on-off button, so that safety is very important. It's a good thing they put a mechanical safety in there as well. So that's how that works. So I'm having trouble getting my fingers just right. So it's very close, very close. So that's going to be one hell of a mech autococker. Very walkable trigger. And I'm sending out parts for milling. Got to buy a few more parts, and then I want to powder coat everything uniform, so it's a nice finish on all the parts. This is going to come apart, get sent out for powder coating along with the body and a few other parts. So it's that's the first step right there, is getting this thing together. So we're going to have a heck of a time when thing is together on the field, and you know, thanks for watching.